Hello boys and girls, this is Mr. Kizik, and this video here we're going to be looking at how do we divide radicals. So what we looked at last time was adding and subtracting and multiplying radicals. Well, now we're going to divide them, and this is something again that you'll be seeing next year in geometry. Um, but how you divide radicals is how it says there. You can divide the coefficients, so whatever numbers in front of the symbol, and then use this quotient rule. And the quotient rule says this: if the indexes, whatever you want to call them, are the same, then that means then I can just, sorry about that, I can just divide by the numbers. And then you would go about simplifying based off of whatever the index tells you. So let's look at an example here. Let's look at number one. So following the two steps, it says divide the coefficients. Remember, coefficients are anything in front of your symbols here. So I'm going to take 12 divided by 2, and I'm going to get 6. Next, I'm going to follow the quotient rule. And the quotient rule says this: if these are the same symbols, if they have the same indices, then I can just divide the numbers. And that's what I'm going to do here. I'm going to do 160 divided by 5, and I'm going to get 32. Now the last step here is just to see, can it be simplified anymore? Can the square root of 32 be simplified? Is there a perfect square that goes evenly into it? You betcha. It's 16. And what's the other one? 2. And then when I simplify that, I get 4 square root 2. But remember, the 6 has to multiply in front of that 4. So my final answer would be 24 square root 2. Okay. Let's look at another one here. Let's look at number 3. Number 3, there's no coefficients there, so therefore I'm done with that. Now let's look at the inside. They have the same indices, so therefore I can divide. So I'm going to take x cubed divided by x squared. Remember, you just subtract the exponents, so 3 minus 2 is 1. And y to the 9th divided by y to the 5th, subtract the exponents, I get y to the 4th. And then you want to see, can you simplify? So you're going to see, well, what's the exponent here? It's a 1 divided by 2, because remember there's a little 2 there in the indices. And I get 0 remainder 1. But then when I do the y variable, I get 2 remainder 0. So my final answer is y squared square root x. Let's look at number 5. No coefficients, I don't need to divide there. So 48 divided by 16, that gives me 3. And in fact, I'm done there. That cannot be, divided anymore. There's no perfect square that goes evenly into square root 3. All right, so again, you're able to divide the whatever's inside the little symbols as long as the indices are the same. So for example, what I'm saying is if I had like cube root of 8, no, that's not going, cube root of 16 divided by the square root of 2, I can't do 16 divided by 2 because this has a 3, there's no 3. So you would leave it as such or simplify it need be. So the main idea of this is, well, this here is rationalizing the denominator. This is something, there's going to be 1 or 2 units in geometry where you would have to rationalize. You might have a square root on the bottom and you have to rationalize it. So there's 2 possibilities. as it says here, first one, a monomial denominator. Remember in the beginning of the year when we did a little bit of vocabulary? Monomial means there's only one term. To get rid of the square root in the bottom, or wherever it may be, you multiply the numerator and denominator by that radical. If it's a binomial, in other words, if there's two things in the bottom of my fraction, then I have to multiply what we call by the conjugate. If you remember back when we did imaginary numbers, that was, if I had this, the conjugate was minus I. As it says here, the same expression, but the opposite sign in the middle. So let's look at number 9. This is a monomial. It has one term. Yes, it has two things. There's a 2 and a square root of 5, but it is really one term. So to get rid of it on the bottom, I have to multiply the top and bottom by the square root of 5. Remember how multiply fractions, you just multiply straight across. So 3 times square root of 5 is 3 square root of 5. And on the bottom, 2 square root of 5 times the square root of 5. Think back to the last lesson here. What happens if I take the square root of something times that same square root? For example, in this case, if I had square root of 5 times the square root of 5, what happens? Well, I get the square root of 25, which is just 5. So really on the bottom, I'm going to have 2 times 5 after I multiply the square root of 5 times the square root of 5 together. And then just finish it off. 2 times 5 is 10. So 3 square root of 5 over 10. Let's look at another one. Let's look at number 11. 3 square root of 12 over 4 square root of 7. Again, it's a monomial, so you multiply top and bottom by the square root of 7. When I do that, on the top I get 3 square root. Now I can multiply 12 and 7 to get me 84. Now on the bottom, when I do square root 7 times square root 7, just like what we did before, I get 7, so the bottom becomes 28. And then, as always, the last step here is you want to see, is there a perfect square that goes evenly into 84? So you would try, 81, that doesn't work. Then you would try 64, that doesn't work. You would try 49, that doesn't work. You would try 36, no. 25, no. 16, no. 9, no. 4. 4 is the biggest perfect square that goes evenly into this. And then also 21. And then this becomes 2 square root 21. So what I have now is this. 3 times 2 square root 21. Because this right here became this. Over 28. I can multiply 3 and a 2, and I get 6 square root 21 over 28. And one last step here. I can simplify 6 over 28, which gives me 3 over 14. So I can write it like this. Don't worry, you will not have something that complicated, nothing that I can think of at least, when we get to that unit of geometry. It'll be more like something like number 9. We're going to do an example with a binomial denominator here because it does come up, like say in the SATs here, and it's good to know how to do this. So this is a binomial because it has two things on the bottom. So that means from what it says on top here, I gotta multiply by the conjugate. So I'm gonna have multiply top and bottom by 4 minus square root 2 and 4 minus square root 2. So I'm multiplying this out here, multiply top, I get 16 minus 4 square root 2. But what happens when I do the bottom? Well, think back to last lesson here. 4 plus square root 2 times 4 minus square root 2. You FOIL it out, and I would get 16 plus 4 square root 2 minus 4 square root 2 minus, and then when I take square root 2 times square root 2, negative square root 2, I get negative 4. What happens is that these two go away here, and I'm left with just a number on the bottom, which is exactly what I want, 12. For all intents and purposes, now, you can leave it as such. However, for future reference here, what you would have to do is you'd have to factor out a 4 on the top, and then I'm left with 4 minus square root 2 all over 12. And then this simplifies here and gives you 4 minus square root 2 all over 3. Because 4 over 12 becomes 1 over 3. That's a complicated one there. And, like I said, for next year, not really going to know that. But if you are going to Algebra 3, this is something that you will need to know how to do, and it will be taught to you again. I'm going to end the video here, and let's see, for your homework, just check Google Classroom what your homework will be. All right? If you have any questions or concerns, please feel free to message me. This is Mr. Kizik, signing off.